Explain the LTE 4G architecture and its key components.
3, 2, 1, 0.
LTE architecture comprises the evolved eNodeB, eNodeB, Mobility Management Entity, MME, Serving Gateway, SGW, and Packet Data Network Gateway, PGW. These components manage radio resources, mobility, session management, and data traffic to external networks. What is the role of the eNodeB in 4G networks?
3, 2, 1, 0.
eNodeB is responsible for radio resource management, handover decisions, and traffic management. It connects the user equipment, UE, to the core network and facilitates data and signaling transmission. Describe the function of the MME in LTE.
3, 2, 1, 0.
The Mobility Management Entity, MME, handles signaling for mobility, session management, and authentication in LTE. It is a key control plane entity in 4G and does not handle user data traffic directly. How does handover work in LTE, and what types are there?
3, 2, 1, 0.
LTE supports hard handovers with break-before-make transitions, primarily using X2 and S1 handovers between eNodeBs. It enhances user experience by reducing latency during network transition. Explain the differences between FDD and TDD in LTE.
3, 2, 1, 0.
FDD, Frequency Division Duplex, uses separate frequencies for uplink and downlink, while TDD, Time Division Duplex, uses time slots for both. FDD is more efficient for symmetric data, while TDD is often preferred for asymmetric data. What is VoLTE, and why is it important?
3, 2, 1, 0.
Voice over LTE, VoLTE, allows high-quality voice calls over LTE networks, offering better call quality and reduced call setup times compared to 3G. It uses the IP Multimedia Subsystem (IMS) architecture. Describe the differences between IPv4 and IPv6 in the context of LTE.
3, 2, 1, 0.
IPv6 offers a larger address space, supporting the massive number of devices in 4G, 5G networks, while IPv4 has limited addressing. LTE supports both, but IPv6 is preferred for scalability and device compatibility. How does cost, quality of service, work in LTE networks?
3, 2, 1, 0.
LTE implements cost by assigning specific classes to bearers, controlling latency and prioritization. It ensures essential services like VoLTE get necessary resources, enhancing user experience. What are some security mechanisms in LTE?
3, 2, 1, 0.
LTE security includes mutual authentication, encryption of user data, integrity protection, and temporary identities. Key management protocols protect data and prevent unauthorized access. Explain the role of the EPC, Evolved Packet Core, in LTE.
3, 2, 1, 0.
The EPC provides IP-based connectivity and services, comprising MME, SGW, and PGW. It handles user session management, mobility, and data delivery to external networks. How does LTE support mobility and seamless transitions?
3, 2, 1, 0.
LTE handles mobility through handovers. X2, S1, optimized for low latency and minimal packet loss during movement. It ensures continuous service with minimal disruption for users. What is carrier aggregation in LTE?
3, 2, 1, 0.
Carrier aggregation combines multiple frequency carriers to increase bandwidth, achieving faster speeds and improved network capacity. It's a key feature of LTE Advanced. Describe LTE's network slicing capability and its benefits.
3, 2, 1, 0.
LTE allows network slicing in later versions, which segments the network for different service needs, improving efficiency and customization for IoT, high-speed, and low-latency requirements. What are the primary differences between LTE and LTE Advanced?
3, 2, 1, 0.
LTE Advanced introduces features like carrier aggregation, higher-order MIMO, and advanced interference management, enabling faster data rates and more efficient spectrum use compared to LTE. How is MIMO used in LTE networks?
3, 2, 1, 0.
MIMO, multiple input, multiple output, improves data throughput and signal quality by using multiple antennas at the transmitter and receiver, supporting various configurations like 2x2, 4x4. How does LTE prioritize emergency calls?
3, 2, 1, 0.
LTE has preemption features, allowing emergency calls to be prioritized by adjusting costs and preempting other sessions if needed, ensuring fast access in emergencies. Explain the function of SGW and PGW in LTE.
3, 2, 1, 0.
The SGW routes and forwards data packets, handling mobility between eNodeBs, while the PGW connects to external networks, managing IP address allocation, costs, and billing. What is IMS in the context of LTE?
3, 2, 1, 0.
IMS, IP Multimedia Subsystem, is a framework enabling multimedia services like VoLTE. It integrates voice, messaging, and video over IP, providing rich communication capabilities over LTE. Describe the basic process of LTE call setup.
3, 2, 1, 0.
LTE call setup involves establishing a session via the MME, authenticating with HSS, and establishing a data bearer between the eNodeB and EPC components like SGW and PGW. How does LTE handle roaming?
3, 2, 1, 0.
LTE roaming uses interfaces like S8 for data forwarding between home and visited networks, allowing seamless service continuity for users in different regions. What is the purpose of the X2 and S1 interfaces in LTE?
3, 2, 1, 0.
X2 enables direct communication between eNodeBs, facilitating fast handovers, while S1 link the eNodeB to the EPC, handling user and signaling traffic. How does LTE manage interference, especially in dense urban areas?
3, 2, 1, 0.
LTE employs techniques like fractional frequency reuse, ICIC, inter-cell interference coordination, and advanced antenna techniques to mitigate interference, enhancing coverage in high-density areas. Can you explain the concept of a bearer in LTE?
3, 2, 1, 0.
A bearer in LTE is an IP packet flow with specific COS attributes. It ensures data is transmitted with appropriate latency, priority, and reliability. What is the difference between a serving cell and a neighbor cell in LTE?
3, 2, 1, 0.
The serving cell is the cell currently providing the strongest signal to the user, while neighbor cells are adjacent cells the UE monitors for handover suitability. How does LTE differ from 3G in terms of data transfer?
3, 2, 1, 0.
LTE is fully IP-based, unlike 3G, and provides higher data rates, lower latency, and better spectral efficiency, making it more suitable for data-intensive applications. What is a PDP context in LTE?
3, 2, 1, 0.
A PDP, Packet Data Protocol, context defines a session between the UE and PGW, establishing parameters like IP address, COS, and charging for data transfer. What is the role of the HSS in an LTE network?
3, 2, 1, 0.
The Home Subscriber Server, HSS, is a centralized database that stores user subscription data, including authentication credentials, subscription information, and mobility management. It assists MME in user authentication and session establishment. Explain the concept of latency in LTE and how it is managed.
3, 2, 1, 0.
Latency in LTE is minimized through efficient packet scheduling and a flat IP architecture. The system is optimized for low latency services, achieving around 10 milliseconds in optimal conditions, critical for applications like VoIP and online gaming. How does LTE handle IP address allocation for users?
3, 2, 1, 0.
IP address allocation is managed by the PGW, which assigns either IPv4, IPv6, or both based on device capability and network support. LTE can provide persistent or dynamic IP addresses, tailored to different user needs. What are dedicated and default bearers in LTE, and why are they important?
3, 2, 1, 0.
A default bearer provides basic connectivity with best effort costs, while dedicated bearers are established for applications needing specific cost levels, e.g., VoLTE. This structure enables flexible traffic management and service prioritization. Describe the concept of idle mode in LTE and its advantages.
3, 2, 1, 0.
In idle mode, the device reduces signaling by disconnecting from the radio channel while still being reachable. Via paging, it conserves power and network resources until data activity resumes, at which point it transitions back to connected mode. What is the purpose of the tracking area code, TAC, in LTE?
3, 2, 1, 0.
The tracking area code, TAC, uniquely identifies a region within an LTE network for efficient location management. It allows the MME to page users only within specific areas, minimizing unnecessary signaling and improving network efficiency. How does LTE utilize OFDMA and SCFDMA, and why are they important?
3, 2, 1, 0.
LTE uses OFDMA, orthogonal frequency division multiple access, for downlink, which improves spectral efficiency, and SCFDMA, single carrier frequency division multiple access, for uplink, which reduces peak to average power ratio, enhancing battery life in mobile devices. What are the main LTE frequency bands, and why are they significant?
3, 2, 1, 0.
LTE supports a wide range of frequency bands from low bands, 700 MHz, for broad coverage to high bands, 3.5 GHz, for dense urban areas. The variety allows for optimized deployment across different geographies and user densities. Describe how eNodeB, Enhanced Multimedia Broadcast Multicast Service, works in LTE.
3, 2, 1, 0.
eNodeB enables LTE networks to broadcast media to multiple users simultaneously, conserving network resources for large-scale live video, TV services, and software updates. This multicast technology is ideal for high-demand content like sporting events. What is the significance of the SGW and PGW separation in LTE?
3, 2, 1, 0.
The Serving Gateway, SGW, manages data traffic for active users and their mobility, while the Packet Gateway, PGW, connects to external networks. Separating these roles helps balance data traffic management and external connectivity needs more efficiently. Explain the purpose of the X2 handover and how it differs from S1 handover.
3, 2, 1, 0.
The X2 handover allows for direct eNodeB to eNodeB transitions, minimizing latency by avoiding core network involvement. In contrast, S1 handovers involve the MME, useful when no X2 connection exists between the eNodeBs. How is congestion managed in LTE networks?
3, 2, 1, 0.
LTE uses congestion management techniques such as cost prioritization, dynamic resource allocation, and admission control to balance network load. This ensures high-priority services maintain their quality even under heavy network traffic. What is EUTRAN, and what are its primary functions?
3, 2, 1, 0.
The Evolved Universal Terrestrial Radio Access Network, EUTRAN, manages all radio communications between UEs and the core network. It performs handovers, resource allocation, and signal processing to optimize data delivery. How does LTE implement data encryption for security?
3, 2, 1, 0.
LTE uses encryption techniques like SNO 3G and AES, Advanced Encryption Standard, to protect data confidentiality over the air interface, ensuring secure transmission between devices and the network. Describe the role of SRVCC, Single Radio Voice Call Continuity, in LTE. SRVCC enables seamless handover of ongoing voice calls from LTE to legacy 3G, 2G networks if LTE coverage is lost, ensuring uninterrupted service for users in areas with mixed network coverage. What is HARQ, and why is it important in LTE? HARQ, Hybrid Automatic Repeat Request, is a retransmission technique that combines error correction with retransmissions. It reduces data loss, maintaining high reliability and better throughput for data transmission in LTE. Explain the purpose and functionality of cell reselection in LTE. Cell reselection in LTE allows idle UEs to select the best available cell based on signal quality, ensuring efficient resource usage and optimized coverage. This process helps devices switch cells smoothly without active communication. What is the purpose of random access procedures in LTE? Random access in LTE enables UEs to establish a connection with the network when entering active mode, either for initial access, handover, or re-establishing connection after interruption. It's essential for managing resources and initial uplink synchronization. Describe EICIC, Enhanced Inter-Cell Interference Coordination, and its benefits.
3, 2, 1, 0.
EICIC reduces interference in dense networks by allowing macrocells and small cells to coordinate. Resource allocation, improving user experience in congested areas by reducing signal degradation from neighboring cells. How does LTE handle paging for idle UEs?
3, 2, 1, 0.
LTE uses paging to notify idle UEs about incoming data or calls, minimizing power consumption and network signaling by only activating UEs when necessary. The MME manages paging requests, limiting them to relevant tracking areas. Explain the difference between Cost Class Identifier (QCI) and Allocation and Retention Priority (ARP) in LTE.
3, 2, 1, 0.
QCI defines the cost parameters for various services, e.g., latency, priority, while ARP determines the priority for resource allocation in congestion scenarios, ensuring critical applications maintain connectivity. What is the importance of MME pooling in LTE?
3, 2, 1, 0.
MME pooling distributes users across multiple MMEs, enhancing reliability and load balancing. It also allows for redundancy, reducing service disruption in case one MME fails, ensuring high availability. Describe the purpose of DRX, discontinuous reception, in LTE.
3, 2, 1, 0.
DRX allows UEs in idle mode to cycle between active and sleep states to conserve battery life, activating only periodically to check for network messages. DRX parameters are adjustable based on user activity. How does LTE support location-based services? Pounds.
3, 2, 1, 0.
LTE integrates GPS and cell tower triangulation to provide location-based services, useful for applications like emergency services, navigation, and targeted marketing. Network-based positioning complements GPS accuracy. Explain the concept of semi-persistent scheduling, SPS, in LTE.
3, 2, 1, 0.
SPS allows periodic transmission scheduling, mainly for VoLTE services, to reduce control signaling overhead. Instead of scheduling each transmission individually, the network assigns resources in advance, improving efficiency for services with predictable patterns. How does LTE handle error correction in data transmission?
3, 2, 1, 0.
LTE uses both FEC, forward error correction, via turbo coding, and HARQ, hybrid automatic repeat request, to detect and correct errors. FEC corrects errors at the receiver, while HARQ allows retransmission of corrupted packets, enhancing reliability. What are physical resource blocks, PRBs, in LTE, and why are they important?
3, 2, 1, 0.
PRBs are the smallest units of resource allocation in LTE, consisting of 12 subcarriers over a 0.5 milliseconds duration. They enable flexible bandwidth allocation to user equipment, enhancing network efficiency and allowing dynamic distribution based on demand. Describe the role of the GTP protocol in LTE networks.
3, 2, 1, 0.
GTP, GPRS tunneling protocol, enables tunneling for data packets between the eNodeB, SGW, and PGW, supporting user mobility. GTPU carries user data, while GTPC handles control messages, ensuring seamless data transport across LTE core components. Explain the purpose of RRC, radio resource control, in LTE.
3, 2, 1, 0.
RRC manages signaling between the UE and eNodeB, handling functions like connection setup, mobility control, and security key exchange. It plays a critical role in establishing and maintaining UE connections and enabling efficient handovers. What is cell edge in LTE, and how is it managed?
3, 2, 1, 0.
Cell edge refers to areas at the boundary of LTE cells, where signal strength and quality often degrade. LTE uses techniques like ICIC, inter-cell interference coordination, and EICIC in LTE Advanced to minimize interference and improve coverage in these areas. How does LTE achieve high data rates in uplink and downlink?
3, 2, 1, 0.
LTE employs technologies like OFDMA for downlink, SCFDMA for uplink, MIMO, and carrier aggregation. These technologies maximize spectral efficiency, improve signal quality, and provide flexible bandwidth usage, achieving high data rates for end users. What is the purpose of TTI, transmission time interval, in LTE?
3, 2, 1, 0.
TTI, usually set at 1 millisecond in LTE, represents the time over which data transmission is scheduled for a user. This short interval allows for faster feedback on channel conditions, essential for real-time services and efficient resource scheduling. Describe the difference between S1 Flex and S1 MME pooling in LTE.
3, 2, 1, 0.
S1 Flex enables multiple eNodeBs to connect to multiple MMEs, improving resilience and load balancing. S1 MME pooling allows a single eNodeB to connect to multiple MMEs within the same pool, providing flexibility in resource management and fault tolerance. Explain how LTE supports Internet of Things, IoT, devices.
3, 2, 1, 0.
LTE standards have evolved to support IoT through features like LTE-M and NB-IoT, which provide low power, extended range, and reduced complexity. These technologies are ideal for battery-operated devices requiring long-range connectivity with limited data needs. What are reference signals in LTE, and why are they important?
3, 2, 1, 0.
Reference signals provide known data patterns for channel estimation, allowing the receiver to measure and compensate for channel impairments. LTE includes several types, like cell-specific reference signals, which assist with signal quality measurement and handover decisions. How does LTE handle power control, and why is it crucial?
3, 2, 1, 0.
LTE uses both open-loop and closed-loop power control to optimize transmit power levels, ensuring signal quality while minimizing interference and conserving battery power. Proper power control maintains network efficiency, especially in dense environments. Describe the impact of Doppler effect in LTE and how it is mitigated.
3, 2, 1, 0.
The Doppler effect, due to high-speed movement, can cause frequency shifts affecting signal quality. LTE mitigates this through adaptive modulation and coding, Doppler shift-resistant channel estimators, and resource allocation adjustments based on mobility profiles. What is the significance of the downlink control information, DCI, in LTE?
3, 2, 1, 0.
DCI carries essential control information for UE scheduling, including resource allocation, MCS, modulation and coding scheme, and HARQ commands. Accurate DCI decoding ensures the UE can receive and process downlink data effectively, maintaining smooth communication. Explain the purpose of Packet Data Convergence Protocol, PDCP, in LTE.
3, 2, 1, 0.
PDCP provides header compression, encryption, and integrity protection for IP data in LTE. It also handles packet reordering during handovers, ensuring data integrity and security between UE and eNodeB for both control and user data. What is RACH, Random Access Channel, and why is it important in LTE?
3, 2, 1, 0.
RACH is used for initial connection establishment, handover, and uplink synchronization. It enables UEs to request resources from the network, allowing LTE to efficiently manage resource allocation for new and transitioning users. How does LTE achieve backward compatibility with 3G networks?
3, 2, 1, 0.
LTE uses CSFB, circuit switched fallback, for voice and SRVCC for ongoing voice call continuity to hand over users to 3G when LTE is unavailable. This backward compatibility ensures users remain connected even in areas without LTE coverage. What is the purpose of the Serving Cell Reference Signal, SRS, in LTE?
3, 2, 1, 0.
SRS is a unique signal sent by the UE to help the eNodeB assess uplink channel quality. It enables more accurate uplink scheduling, adapting transmission parameters to match current channel conditions, improving uplink performance. Describe the process of cell selection and reselection in LTE.
3, 2, 1, 0.
Cell selection is based on signal quality when a UE initially connects, while reselection occurs when a UE in idle mode detects a stronger signal in another cell. LTE uses measurement criteria to determine the optimal cell, enhancing network efficiency and user experience. Explain the purpose of the UU interface in LTE.
3, 2, 1, 0.
The UU interface is the air interface between the UE and eNodeB. handling all data and signaling over radio waves. It defines protocols and standards for secure, reliable communication, playing a central role in data transmission within LTE. What are the differences between RLC, radio link control, modes in LTE?
3, 2, 1, 0.
RLC operates in 3 modes. Transparent mode, no header, unacknowledged mode, error detection, and acknowledged mode, error correction. Each mode suits different services, balancing efficiency, reliability, and overhead based on data requirements. How is downlink scheduling managed in LTE?
3, 2, 1, 0.
Downlink scheduling assigns resources to UEs based on channel quality, cost requirements, and traffic load. Scheduling algorithms, like proportional fair and round robin, help optimize network performance and user experience by balancing speed, fairness, and resource availability. What is the purpose of CQI, channel quality indicator, in LTE?
3, 2, 1, 0.
CQI is reported by the UE to the eNodeB, indicating the quality of the downlink channel. The eNodeB uses CQI to adjust modulation and coding, optimizing data rates and reliability based on real-time channel conditions. Describe the role of IMS, IP Multimedia Subsystem, in VoLTE.
3, 2, 1, 0.
IMS enables VoLTE by handling voice, video, and messaging services over IP. It provides a standardized platform for multimedia services, allowing operators to integrate advanced communication features and ensure compatibility across devices and networks. What is the impact of MIMO, multiple input multiple output, on LTE performance?
3, 2, 1, 0.
MIMO improves data throughput and spectral efficiency by utilizing multiple antennas for transmission and reception. LTE supports MIMO configurations like 2x2 and 4x4, which significantly enhance download speeds and reliability in multipath environments. What is the function of EICIC, Enhanced Intercell Interference Coordination, in LTE?
3, 2, 1, 0.
EICIC reduces interference in densely deployed networks, especially with small cells. It coordinates resource allocation across cells, utilizing features like almost blank subframes, ABS, to limit interference in overlapping areas, improving throughput and coverage. Explain the purpose of carrier aggregation, CA, in LTE Advanced.
3, 2, 1, 0.
CA combines multiple LTE carriers to increase bandwidth and achieve higher data rates. It allows users to utilize wider bandwidth by aggregating up to 5 carriers, providing enhanced peak rates and better spectrum utilization. Describe how quality of service, COS, is managed in LTE.
3, 2, 1, 0.
LTE implements COS via bearers with predefined parameters such as GBR, guaranteed bit rate, and non-GBR for specific data flows. Cost class identifiers, QCIs, prioritize traffic, ensuring essential services receive necessary resources based on latency and priority requirements. How does LTE implement IPv6 for future network compatibility?
3, 2, 1, 0.
LTE supports IPv6 by default, enabling longer IP addresses to meet the needs of more devices. Dual stack IPv4, IPv6 is also supported for backward compatibility, ensuring that LTE networks remain compatible with both current and next-gen IP standards. What is the function of SRVCC, Single Radio Voice Call Continuity, in LTE?
3, 2, 1, 0.
SRVCC allows ongoing VoLTE calls to seamlessly transfer to legacy 2G, 3G networks when users move out of LTE coverage, maintaining call continuity by utilizing a single radio interface to manage the transition. How does LTE implement security for data transmissions?
3, 2, 1, 0.
LTE uses NAS and NAS security with AES encryption and integrity protection for signaling and user data mutual authentication between the UE and network, plus encryption keys derived from SIM authentication, provides a secure data environment. Describe the impact of cyclic prefix (CP) in OFDMA for LTE.
3, 2, 1, 0.
CP mitigates intersymbol interference by adding a guard interval to each OFDMA symbol, ensuring smooth data transmission over multipath channels. LTE offers both normal and extended CP, where extended CP is used in highly reflective environments. What is the purpose of the X2 interface in LTE architecture?
3, 2, 1, 0.
The X2 interface connects eNodeBs, enabling direct communication for functions like handovers, load management, and interference coordination. It reduces signaling latency and allows eNodeBs to collaborate without relying on the core network. Explain the concept of HARQ, Hybrid Automatic Repeat Request, and its use in LTE.
3, 2, 1, 0.
HARQ combines FEC and retransmissions to correct errors in real time, enhancing data reliability. It stores incorrectly received packets and combines them with retransmissions for error correction, maximizing efficiency over LTE's fast transmission intervals. How does LTE support seamless handovers across cells?
3, 2, 1, 0.
LTE uses UE measurements, including reference signal received quality, RSRQ, and reference signal received power, RSRP, to trigger handovers. Handover types, such as hard and soft handovers, ensure continuous connectivity and costs for mobile users. Describe the role of OFDMA in LTE's downlink transmission.
3, 2, 1, 0.
OFDMA divides bandwidth into small subcarriers, each independently modulated, allowing simultaneous data streams to multiple users. It enhances spectral efficiency and minimizes interference, especially beneficial in high-traffic areas. What is the purpose of the EPC, Evolved Packet Core, in LTE networks?
3, 2, 1, 0.
The EPC connects LTE radio access to the Internet and other networks, handling user data, mobility, and costs. Key components include the Serving Gateway, SGW, and PDN Gateway, PGW, which manage data transfer and routing for user devices. How does LTE manage idle mode mobility?
3, 2, 1, 0.
LTE uses cell reselection for idle mode mobility, where the UE scans for and selects the best cell based on RSRP and RSRQ. It allows devices to save battery while ensuring they reconnect promptly when needed. What are the functions of PDCCH, Physical Downlink Control Channel, in LTE?
3, 2, 1, 0.
PDCCH carries critical control information, including resource allocation and HARQ information, directing UEs to their data in the downlink. It ensures timely and accurate delivery of control messages essential for efficient data scheduling and channel management. Explain the importance of spectral efficiency in LTE.
3, 2, 1, 0.
Spectral efficiency measures data transmission rate per unit bandwidth. LTE achieves high efficiency with technologies like OFDMA, MIMO, and high-order modulation, enabling more data transmission within limited spectrum and maximizing resource utilization in crowded networks. How does LTE utilize frequency reuse to enhance capacity?
3, 2, 1, 0.
LTE supports universal frequency reuse factor of 1, enabling all cells to use the same frequency band. Interference management techniques like EICIC and advanced scheduling mitigate potential interference, allowing for efficient frequency usage. Describe the role of eNodeB, Evolved eNodeB, in LTE.
3, 2, 1, 0.
The eNodeB is LTE's base station, managing radio resources, scheduling, and user data transmission. It connects to both UEs and the EPC, handling essential functions like signal modulation, encoding, and handovers to maintain network connectivity and user experience. What is TDD, time division duplex, in LTE, and how does it differ from FDD?
3, 2, 1, 0.
TDD uses the same frequency for uplink and downlink but alternates in time slots, while FDD uses separate frequencies for each. TDD is advantageous in asymmetric traffic conditions and offers flexible resource allocation, although it requires precise synchronization. Explain the purpose of MBMS, Multimedia Broadcast Multicast Services, in LTE.
3, 2,
MBMS enables efficient broadcast of multimedia services to multiple UEs. Ideal for live events or emergency alerts. By using shared resources for multicast, LTE reduces network load, delivering content to a large audience without duplicating data for each user. How does LTE optimize power usage for user devices? LTE employs discontinuous reception (DREX) in idle mode, where UEs periodically wake to check for messages, saving battery power. Adaptive power control, based on signal strength and network conditions, further enhances efficiency by adjusting transmit power. What is the significance of SINR, signal to interference plus noise ratio, in LTE?
3, 2, 1, 0.
SINR indicates signal quality by measuring usable signal strength relative to interference and noise. A high SINR enables higher modulation and coding schemes, improving data rates, while low SINR may trigger handovers to maintain signal quality. Describe the function of the SGW, serving gateway, in LTE.
3, 2, 1, 0.
The SGW serves as the anchor point for the user plane, forwarding data between the UE and PGW and managing handovers between eNodeBs. It also handles data packet buffering during LTE to 3G, 2G handovers, maintaining connection stability for users on the move. How is VoLTE, voice over LTE, different from traditional voice calls?
3, 2, 1, 0.
VoLTE routes voice calls over IP within the LTE network, enabling higher quality calls compared to traditional circuit-switched networks. It provides simultaneous voice and data services and integrates with IMS, allowing enhanced services like video calling and messaging. How does LTE handle packet scheduling for multiple users?
3, 2, 1, 0.
LTE uses the MAC scheduler to allocate resources dynamically, prioritizing users based on factors like costs, channel quality, and required bandwidth. Proportional fair scheduling and round-robin are common methods used to maximize spectral efficiency while maintaining fairness. Explain the purpose of OFDM, orthogonal frequency division multiplexing, in LTE downlink.
3, 2, 1, 0.
OFDM splits data across multiple closely spaced subcarriers, minimizing interference by making them orthogonal. This allows high data rates and efficient use of spectrum, which is ideal for handling high-capacity traffic in urban LTE networks. What is the function of the RRC, radio resource control, layer in LTE?
3, 2, 1, 0.
The RRC layer manages signaling between UEs and eNodeBs, handling connection setup, handovers, security control, and mobility. It plays a crucial role in controlling radio resources, ensuring stable and efficient connections based on user needs and network capacity. How does LTE implement low latency for real-time applications?
3, 2, 1, 0.
LTE achieves low latency with HARQ for fast retransmissions, minimized packet overhead, and efficient scheduling. Techniques like shortened TTI and DRX cycles further reduce latency, enabling applications like gaming and VoLTE to run smoothly with minimal delay. Describe the use of EUTRAN in the LTE architecture.
3, 2, 1, 0.
EUTRAN, Evolved UMTS Terrestrial Radio Access Network, is the radio access network for LTE, comprising eNodeBs. It facilitates communication between UEs and the EPC, managing resource allocation, mobility, and cost to support seamless data and voice services over LTE. What is the role of PGW, Packet Data Network Gateway, in LTE's core network?
3, 2, 1, 0.
The PGW connects the LTE network to external IP networks, handling IP address allocation, COS enforcement, and mobility between LTE and non-LTE networks. It acts as a gateway to the Internet, ensuring seamless data connectivity for users. How does LTE achieve higher spectral efficiency compared to previous networks?
3, 2, 1, 0.
LTE combines OFDMA, MIMO, and adaptive modulation to optimize spectral efficiency. By assigning multiple subcarriers and antennas to users and dynamically adapting to channel conditions, LTE transmits more data per hertz, which is critical in high-traffic environments. What is the importance of ERAB, Evolved Radio Access Bearer, in LTE?
3, 2, 1, 0.
ERAB links user applications with the core network, ensuring COS parameters align with service needs. It establishes and maintains data flow between the UE and EPC, managing resources and handling priorities for each session to meet COS requirements. Explain the concept of network sharing in LTE.
3, 2, 1, 0.
LTE allows network sharing among operators via techniques like MOCN, Multi-Operator Core Network, and GWCN, Gateway Core Network. It enables cost savings by sharing radio access and core network elements, making network deployment more efficient. What is the use of transmission mode, trademark, in LTE, and how many modes are there?
3, 2, 1, 0.
TMs configure eNodeB transmission schemes based on the network's needs. LTE has 10 TMs, including SISO, MIMO, and beamforming, optimizing data rates, coverage, and quality. TMs allow adaptive use of antennas to enhance performance under varying channel conditions. How does LTE support emergency communications?
3, 2, 1, 0.
LTE offers priority access and preemption for emergency services through evolved COS frameworks. During emergencies, LTE can prioritize critical calls and data, allowing first responders reliable network access, even under heavy network loads. Describe how LTE handles roaming across different networks.
3, 2, 1, 0.
LTE supports seamless roaming via Mobility Management Entity (MME) and SGW coordination, handling authentication, security, and session continuity as users move across networks, ensuring stable service without user intervention. What is an S1 interface, and why is it important in LTE architecture?
3, 2, 1, 0.
The S1 interface connects the eNodeB to the EPC, specifically to MME and SGW. It manages signaling and data transfer between the radio network and the core, crucial for handling user sessions, mobility, and ensuring uninterrupted service across different cells. How does LTE handle device authentication? LTE uses mutual authentication between UE and the network through the MME and HSS. It generates session keys based on SIM credentials, preventing unauthorized network access and ensuring secure data exchanges. What is TTI bundling, and why is it used in LTE? TTI bundling sends multiple identical transmissions within a short interval, improving coverage in poor signal areas. It is especially useful for VoLTE in fringe areas, allowing reliable voice calls by increasing signal robustness. How does LTE ensure quality of experience (QoE) for users? LTE maintains QoE with features like adaptive bitrate, cost prioritization, and low latency configurations. It monitors network conditions in real time, adjusting data rates and resources to deliver consistent, high-quality service for diverse applications. Explain the purpose of PCRF, policy and charging rules function, in LTE.
3, 2, 1, 0.
PCRF controls and enforces policies for data sessions, setting costs and managing charging rules based on user profiles and service types. It helps optimize network resources while maintaining a balance between user experience and cost efficiency. How does LTE implement interworking with Wi-Fi?
3, 2, 1, 0.
LTE interworks with Wi-Fi through the EPC, using interfaces like S2A to provide seamless service continuity. By offloading traffic to Wi-Fi, LTE reduces load on cellular networks, allowing efficient use of resources and improving user connectivity. What is the function of MCS, modulation and coding scheme, in LTE? MCS selects modulation order and coding rate based on channel quality, balancing data rate and reliability. Higher MCS levels improve data throughput in good conditions, while lower MCS levels ensure stability under poor network conditions. How does LTE use cell ID in location tracking?
3, 2, 1, 0.
LTE uses cell ID as a basic location method, associating UEs with eNodeB sectors. For finer location accuracy, it combines cell ID with timing advance and other parameters, assisting emergency services and supporting location-based applications. What is the purpose of EPCDNS in LTE?
3, 2, 1, 0.
EPCDNS resolves domain names to IP addresses within the LTE network, routing UE requests to the appropriate service nodes. It enables efficient service access, critical for network functionalities like handovers and service continuity. How does LTE handle signaling overload during high-demand events?
3, 2, 1, 0.
LTE mitigates overload with priority queuing, load balancing across eNodeBs, and back-off timers. Dynamic resource adjustment and optimized signaling reduce network strain, ensuring essential services remain accessible during events like concerts or emergencies. Describe the LTE MME's role in managing UE states.
3, 2, 1, 0.
The MME controls UE states, e.g., idle, connected, and manages mobility across cells. It orchestrates idle mode tracking, active mode handovers, and session management, ensuring efficient power use and smooth transitions as users move within or between networks. Explain the concept of load balancing in LTE networks.
3, 2, 1, 0.
LTE dynamically redistributes traffic across cells by adjusting transmit power, changing cell priorities, and redirecting connections. Load balancing maintains consistent service quality by optimizing resource utilization across network cells, preventing congestion,